So in this one exercise, we're going to do everything from start to finish of our hypothesis test. So we have this question, is yawning contagious? In this Mythbusters episode, they went ahead and had subjects either seated with a yawn, so they had someone yawn in front of them, or they were not, and then they recorded whether or not the person in the room yawned. And so we can see here are kind of our explanatory variables, whether or not they were given a yawn seed, and we have our response variable, whether or not the subject then yawned. So if we wanted to set up a hypothesis test, the first thing we would need to do is think about what our hypotheses are. So our null hypothesis, we have two groups, yawn seed and non-yawn seed, and we have a proportion, right? We can get this out. We're talking about a categorical variable, whether or not a subject yawned. So our null hypothesis is going to be, is the proportion of people who had a yawn seed who then yawned the same as the proportion of those who did not get that yawn seed and then still yawned? Whoa, that was a lot of saying yawn. But is the proportion the same for this group as it is for this group, right? Cool. And if we wanted to, we could even go ahead and start thinking about what our sample proportions are for both of those. Now, we know we don't need to do all of that because StatCrunch is going to do it for us, but we do need to determine for our alternative hypothesis what our direction is. And because we were told that we were studying whether or not yawning was contagious, we are interested in whether this proportion of people who yawned after being seated with a yawn was greater than the proportion of people who yawned without being seated with a yawn. So we've got our hypotheses, we have our data, and so we're ready to go to StatCrunch and have it do all the hard work for us, right? That's not really the hard work, but c'est la vie. All right, so we're coming to stat, proportion stats. We have our two samples, those with the yawn seed and those without. And we have our summary because we didn't get the raw data. And we're going to go ahead and put in here, it looks like our first group, sample one, we're going to call that the yes group. They had 10 successes, 10 yeses, out of a total of 34 people who got a yawn seed. We had 4 successes, 4 people yawned in our non-seeded group with 16, and we want to show a greater than, right? We want to show P1 is greater than P2. So they do it setting up the difference in proportions, which follows more from our sampling distribution, that difference in sample proportions, but the direction of our inequality is the same, whether we set it up like I did or we set it up as the difference like StatCrunch does. So compute, there we go. Oops, I need more actually before I screenshot this because I need to scroll over. Actually, let me just make this big so I can get the whole thing. It looks like we have a difference of about 4% between these two groups, which gives us a very unremarkable and unimpressive z-score, right? There's definitely some stuff helping them out here in terms of their conclusion, but not a whole lot, right? So we could go ahead. We've done step one. We already wrote down our hypotheses. Step two, we're going to say z is equal to 0.32. Already alarm bells should be going off, right? I don't like writing z-stat because that doesn't really mean anything. That's like a StatCrunch word. So z is equal to 3.2. We know, or 0.32. We know that's not impressive. That's not unusual. And then to hammer that point home, we get out a p-value of 0.3729, almost a 40% chance of that happening if there were no difference. And so, oof, not looking good for us here. So we go to step 4. We could say our p-value is most definitely larger than any reasonable alpha level. It's larger than ours at 0.5. So we're going to fail to reject the null. So if we're doing our last step, step 5, we would say, I'll be better about this. I'll use all of the words that I'm supposed to use. At a 5% significance level, though truly even at a 10% significance level, which is the largest really acceptable significance level people use, we do not have enough evidence to conclude And then we could say the proportion of people who blah, 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 blah. Or we could just go through the wording of this problem, which is what we're trying to do, uh, that yawning is contagious. I don't think we can support what they said in their episode. Yes, the actual data supports them, right? If we did this math, 10 over 34 is greater than 4 over 16. Yes, more people yawned who were seated with the yawn, but not significantly large number. We are, of course, though, dealing with a small number of sample size, because if you really go all the way back to this sample difference right here, right? This difference in proportions is the exact same, almost exact same amount as what we saw in the race and resume sample study. The big difference here, though, is the sample sizes. In the race and resume study, we had sample sizes over 2,000, and here we have sample sizes of 34 and 16. So the sample size is probably the issue here more than anything else. There is, of course, the difference too in the magnitude of those proportions to begin with. So 4% difference doesn't make as big of an impact when our proportions are around 25% as a 4% difference was when our proportions were around 10%. But either way, we're definitely what we would call underpowered for what we want to be able to talk about here. We just have too small of a sample size. And if you really wanted to get into it, we haven't met the conditions for inference, right? We haven't talked about those yet, but if you look back at what we needed for approximate normality for our sampling distribution, we needed all of our expected numbers of successes to be at least 10 for normality. And right here, that 4 out of 16, that's way too small. We're not going to have that NP and NQ being greater than or equal to 10 for that second group especially, not even for the first group. So pulling off a actual test here is a little bit questionable based on the fact that we haven't met our conditions for inference.